And this is the lecture for Module 10, Abstract Classes and Interfaces. This is the last module that we have out of the textbook for the course. And this basically expands upon the notion of inheritance that we've talked about before. It refines it a little bit and provides some different ways that you can think about it and different ways you can implement in your code design. As usual, the outcomes. Please review these when you're done with the module to make sure you understand them. So let's talk first about an abstract method. An abstract method is a method that has no body, that doesn't have any actual executable statements. It only has the signature. Why would you do such a thing? Well, we've talked about this before. When we have a generic class and then we have children of that generic class, the generic class generally doesn't know how the children should behave. That's why we created the children. So there's no value in actually creating a method or defining a method in the generic class. So instead, what you can do is just provide the method signature, and then the children will actually fill out the lines of code in the class. We'll talk about that in a second and have some examples. So generally, you're not even going to instantiate that generic class. There's no value in fully defining it. If you have an abstract method, the class itself must be tagged as abstract. Now, how do you know if you have an abstract method? You actually use the abstract keyword in the signature. So here's an example signature: public, abstract, double, foo being the generic name for a method. So we're saying it's public, its return type is double, its name is foo, and it's abstract. And once you say that, you don't include anything else. You don't include the curly brackets and the executable lines of code or anything like that. It's just the signature. So for example, in the Liang text, they give us some example code. Here's an abstract class. We'll come back to that in a second. And down in the bottom, sure enough, there are some methods that are fully defined, but then we have an abstract method. And what is that method doing? It's doing nothing other than to provide the signature so that when you have the children that are that extend this class, they'll actually flesh out what getArea and getPerimeter do. We've done this really at the beginning of the semester when we were talking about inheritance. The only difference is I didn't use abstract methods or abstract classes. Everything was a concrete method or a concrete class. Okay, an abstract class then. If you have an abstract method, you must put it in an abstract class. It's abstract because it's never going to be instantiated. You will never make an object of this class. The Liang example, this is one of them. And notice that you have an abstract class animal, and it only has one method, and that method is also abstract, so it's just the signature. There is no definition for that method. Well, how do these methods ever get executed? Eventually, you'll extend this class, and you'll extend it with a concrete class that overwrites the method and actually provides the steps that need to occur for that method to execute. By the way, in the example, and I'll probably point it out again when we look at them, the Liang text, for purposes of the example, put several classes in the same file, and you should never do that. There is never a reason for doing that. Every class should have its own file name. All right, so if a class contains an abstract method, it has to be an abstract class. It may contain attributes. It may also contain fully defined methods in addition to the abstract methods. Technically speaking, all of the methods could be fully defined, but then there's really no reason to have an abstract class. Cannot be instantiated. You cannot make an object from that class. It may be part of an inheritance relationship, and basically there's no real restriction on that. Typically, an abstract parent will have either children that are fully defined, concrete children, or will have abstract children. You're allowed to do that. An abstract class can have an abstract child, and then that child can have another child that eventually when you get down the line of descendants, all of the methods are defined and the child is no longer abstract. And I believe there's an example of that from the Liang text. So that's all these abstract classes are about. The idea again is there's no value to trying to define a method for a child you know nothing about yet. So, but there is value in having the signature, because when you design the software, you want to be able to speak to the higher level class, right? So that you can use the children interchangeably. And if that higher level class doesn't have any method signature at all for it, then you wouldn't be able to call that method. An interface is slightly different than an abstract class. The job of an interface is to do what its name is, to provide an interface. What is an interface? Think about how interfaces are used in engineering. You want to take an avionics box and you want to mount it on a bulkhead. And that avionics box has mounting feet, and you're supposed to put bolts through the mounting feet. And then the bulkhead has holes that accept the bolts from the mounting feet. And it's a really good idea if the dimensions of the mounting feet on the box line up with the dimensions of the holes in the bulkhead, so that when you put the bolts through, all the holes line up. If you've ever bought home, IKEA type stuff or home furniture that you need to put together, you can tell if they did a good job or not. Does everything fit? Right? Does everything go together nicely? So it's the same idea in software. What if I'm developing a piece of software and you're developing a piece of software, and we're two separate companies doing it or two separate groups doing it, but our software is supposed to play together by the time we're done? Well, we come up with, here's what the interfaces are. I'm going to send you this data. Here's the data type. You're going to send me this data. This is critical for things like internet communications. I mean, you've all heard of Internet Protocol. What does Internet Protocol mean? It's really a very complex form of what we're talking about here. It's an interface. It says, look, if you're going to push data out on the web, thou shalt do it in this format. And if you're going to receive data from the web, thou shalt do it in this format. Well, if everybody's pushing data and receiving data with the same formats, then data transfer can occur. So the idea is somebody created an Internet Protocol which serves as an interface document. And there are all kinds of protocols. How do you know that your MP3s will play on any MP3 player? Because everybody knows the protocols for MP3s. Think of any kind of file type. Basically, a group of people sat down in a room and said, here's what the protocols will be. Here's what the data structures will be. Now, that doesn't mean that people said what's going to happen with them. They just say, here's what the data is. So an interface is kind of similar. The idea here is it's similar to an abstract class, but it only contains abstract methods. Nothing but abstract methods. And the only attributes that it contains are constants. So that's how it's distinguished from a class. So it only has abstract methods, and if it has any attributes at all, which they often don't, they are constants. The idea again is, if you create this interface and then someone else is creating software, and it may be someone you've never met yet, maybe it's someone, you put some software out in the world with your interface, and then they're going to create software 2 years from now to work with your software, then they look at the interface and say, okay, here's all the signatures for all the methods, and here's all the methods that I have to define in order for my software to work with your software. Interfaces are implemented, not extended. So in the example in the Liang text, they do a public interface editable. So it's actually called an interface, not a class. Public interface editable. And notice editable only has one abstract class. One abstract method. It has no attributes. And then later on in their examples, they say public class fruit implements editable, which means that that method should be defined. Now, oddly enough, the author made it an abstract class, so you're allowed to maintain the method as an abstract signature, but the author fixes that with another layer of inheritance later on. Interestingly enough, you are allowed to both extend and implement. So in this case, again, the author's example, there is a class called animal. It is not it is an abstract class. And there is an interface called edible. And then they create a specific animal called a chicken. And the chicken extends animal because it's a refinement of the generic animal. It's a specific version of the generic animal. But it also implements the edible interface. So you're allowed to do both of these. Notice when we talked about inheritance before, you could only extend from one class. You couldn't have what we call multiple inheritance. In Java, you can only have single inheritance, meaning chicken extends animal and that's it. It can't extend animal and extend something else and extend something else. So the closest we get to multiple inheritance in Java is the ability to extend and to implement. Chicken extends animal, implements edible. By the way, you can only, I better check this, you can only implement one interface. So let's look at some examples of code, and I'll run the code in a separate, in the course setting. The code which is available to you online, we have this geometric object, and then we have circle and we have rectangle, and this is virtually identical to the stuff that I did at the beginning of the semester, except now we're using abstraction to clean things up. So we have an abstract geometric object, which I think I called shape earlier in the semester when I wrote my own. And this thing has some different methods and no attributes, different methods. And then it has down at the bottom two abstract methods. Well, again, why would you do the abstract methods? Because get area. You don't know how to get area for a generic shape. You don't know how to get the perimeter for a generic shape. So there's no value in defining them. Keep them abstract. And then circle extends geometric object, and notice it is not an abstract class, so it has to define all of the methods that were abstract in the geometric object class, and sure enough, we override get area, and we override get perimeter. Similarly, rectangle, same trick. It overrides get area, it overrides get perimeter. Then in the test geometric object class, they define everything up at the generic level. Now notice they never actually create an instance or an object of the geometric object class. They say this is a geometric object as its type, but it's a new circle, so they create the concrete object circle. New rectangle, they create the concrete object rectangle, and then they do this equal area method. But notice what the equal area method is. It's defined at the geometric object level. And we talked about this before. If you did it the other way, you'd have to have an equal area method for two circles, for two rectangles, for one circle and one rectangle, for one rectangle and one circle. But since you do it up at the higher level, you just do it one time for geometric object. We'll go over these in lecture. The other example the author has is this edible, and here what they have is a horrible design because they put all the classes in one file. Abstract class animal, and then chicken extends animal and implements edible, and tiger extends animal. Let's start there. So tiger extends animal. The abstract class animal had a what sound does this animal produce, right? Public abstract string sound. And so you have to, because the tiger is no longer abstract, you have to define that method. Edible is an interface. It says right there, it's an interface. So it's only allowed to have abstract methods and constant attributes. They chose to only put one abstract method in there. And so then they say, okay, we're going to have this abstract class fruit. Now, since it's abstract, that meant that they did not have to define the method. Why did they do that? Because they want this generic class fruit, so then they can go down to the specifics, which are apples and oranges in this case. Once they say apple extends fruit, now they must, because it's no longer abstract, they have to define all of the abstract methods in fruit. Well, what abstract methods are there in fruit? There's none. Oh, yeah, there is, because it implements edible. Therefore, remember, edible had that one abstract method. Now apple is on the hook to actually define that method. And the same thing happens with orange. There's one that chicken extends animal and implements edible. So, because chicken extended animal, it had to override the animal. It had to define the abstract method in the animal class, which is the sound that it makes. And that's had to do it because it extended animal, and it's not an abstract class. So it's sound, there it is, it overrides the sound. It had to do that because that abstract method came from the animal class. And then because it also implements edible, and if you recall, edible has the abstract method about how to eat, it has to give you a actual fully defined how to eat method. Those are the only two methods that are involved, so those are the only two methods that had to be defined. And we'll go over this again in class. All right, so that's all we need to talk about. There's only one lecture this week. This is a fairly small topic, and so I will close here, and I'll see you in class, and we'll talk about it more.